Alright everybody, here we go. 1-6, the coordinate plane. This is maybe one of the harder ones, and for good reason. So let's start with this. Check the skills you'll need. These are the kind of things that you need to understand in order to work through this chapter. And so let's start. One, we're going to start with roots and square roots, and then how you do these, and then how you do these. So we're going to shoot for this, this, and then this. So here we go. Oops. So the first thing you need to know for chapter 1-6 is that this and this are inverse functions, the square root of x. So what does that mean? 5 squared is 25, whereas the square root of 25 equals 5. The other thing you need to know is that when you have something that looks like this, say 2 plus 3, all of that squared, that there's a right way and a wrong way to do this. So you could do it one of two ways. You could say that it is 2 squared plus 3 squared, or you could say that it is 5 squared. Which do you first? Do you do the addition and subtraction, or do you run the square through? This gives us 4 plus 9, which is a total of 13. This gives us 5 squared, which is 25. So the question is, which one of those is correct? Okay, and the answer is that this is wrong, this is correct. You do what's inside the parentheses first, then you do the exponents. Maybe you guys remember PEMDAS, right? Parentheses, exponents, multiplication, division, addition, and subtraction. So PEMDAS says we do it this way. What about the square root? Square root is the same. If you did a problem that looked like this, the square root of 2 squared plus 3 squared, there's two ways to do it. You could say, oh, well, that's the same as the square root of 5 squared, or you could say it is the square root of 4, which is 2 squared, plus 9. The square root of 5 squared is 5, or here we could take the square root of 13. And the answer on this one is that is incorrect. It is correct to do what's underneath the exponent first, or underneath the square root sign. So first you do the squares, then you add them together, and then you take the square root of the whole mess. Alright, so then we're going to get the square root of 13. I don't have a calculator, but I'm just going to take a stab at it and say that it's 3.3 is the answer. Okay, and the answer here is 25. So, exponents, square roots are the inverse function. Do what's inside the parentheses first before you square it. Do what's underneath the square root before you square it. Okay, so now on to what this whole chapter is about. Pythagorean theorem. We're working with triangles in this case, and it looks like this. If you have a triangle, and we're going to call this A, call this B, call this C, and then there's this formula that says A squared plus B squared equals C squared. That's the Pythagorean theorem. If you solve this for C, it looks like this. We're going to swap this around and say the square root of A squared plus B squared equals C. Okay, so what C tells you is the length of that triangle that is opposite of a right angle. Or written differently, it is C equals the square root of A squared plus B squared. Now, what about for a line? For this problem, it's understanding the coordinate plane, and it gives you these lines, but instead of showing you the line like this, and the length of it. Instead, it gives you the coordinates, and you have to figure out how long the line is. That's the kicker, okay? So, let's go ahead and do an example here. So we're going to, the first example, which is this one, is what we just did. We're going to take a halfway step to get to this distance formula here, because it just jumps right into this, and I think it could use a bit of explanation going into it. So let's take this example right here. So we're leading up to the distance formula, except we're going to do it in a slightly smaller step. Okay, so this is not in the book, but this is something that will help you understand it a little bit better. So the distance formula is this idea that if you have a number line, and let's say we're going to call this the 0, and let's just put 2 points here. We're going to call this -2, 1, 2, 3, 4. We're going to call this 4. So you can just look at that and say, oh, well, those are obviously, the distance is clearly 6, because you can just say, well, there's 4 over here and 2 over there, so that is, the distance equals 6. Now, how would you do it using the distance formula? Well, you could do it something like this. The distance formula would say for only in the x direction, we're ignoring the y for now, the distance formula is this. Distance is going to be, we're going to give these a number. We're going to call this x1, and we're going to call this x2. Okay, so the distance is the absolute value of x1 minus x2. So let's just try it out. What is x1? x1 happens to be -2. So we're going to say d, shortening the d for distance, is the absolute value of -2 minus x2, which is 4. Okay, so what do we get? Here we get d equals the absolute value of, what is -2 minus 4 more? Well, that is -6. What does the absolute value mean? The absolute value means it is just the number minus the sign, so in this case d equals 6. Very good, and we already knew that anyway. But let's just try this differently now. Let's just take the distance and let's do it backwards. How about if distance is x2 minus x1? Does that also work? Well, let's check it out. D equals x2 now is 4, and x1 is -1. 4 minus a -1, absolute value. So you guys know the trick where this goes over here and forms a plus. So 4 minus the -1 is the same as 4 plus 1. Okay, so D is now, plus 2. So D is now 4 plus 2, absolute value D equals 6. Oh, so it's the same. So you can do x2 or x1 are essentially interchangeable. Now, what if we do this exact same distance formula, except now we're going to do them in the y direction. So this is the x over here. But what if we do it in the y direction? So now let's make a similar line down here. We'll call this 0, and let's just pick a point. We're going to call this -1, and we'll call this a 1, 2, 3, 4. So in this case, we're just strictly dealing with the y-axis, and so what is the distance here? Well, you can look at it and say, well, it's 4 here and 1 there, so the distance is clearly 5. But how do you do that using the distance formula? This is the step towards being able to do these next problems. So I'm going to say, well, all right, distance is equal to the absolute value of y2 minus y1. All right, so here we go. Distance equals the absolute value of y2. Oops, I guess we're going to need to give these a name. So here we go. We're going to call this 4. Or let's call this one y1. Call this one y2. Doesn't actually matter the order you do it in. So here we go. y2 is 4. y1 is -1, so it's minus a -1. So the distance equals the absolute value of 4 minus a -1 is the same as 4 plus 1. So the distance is 5. And sure enough, that works because that's exactly what we said earlier. So what we just did was we did the distance in the x direction and the distance in the y direction. So now where do we need to go from here? Well, now we need to find the distance in the x direction and the y direction at the same time, and this is where it starts to get a little bit tricky. So, moving on, it's going to look like this. Right here in your book, it says the distance is x squared minus x1 squared plus y2 minus y1 squared. So the distance between the points is you have to do the x first and the y first. Okay? So now what we just did before was the distance in the x direction, or in the y direction, and the distance in the x direction. But now we're going to have to take that and turn it into a triangle. Okay? And so it's going to look like this. This next step looks like this. What if you have a line? Here's our scale, our graph. This is x and y. What if we now have one that looks like this? It's here, and 1, 2, 3, 4, 5. 1, 2, 3, 4. So we now have this line right here. That line is at an angle, but we can break it up into an x. Here's the x. And y. Here's the y. Alright, so now what you can say is, oh, I see. Well, we're going to call this distance in the x direction. Let's just go ahead and call it A. We'll call this distance B and this distance C. And using the Pythagorean theorem, which we did before, which is right here, we said that A, B, and C, that C equals the square root of A squared plus B squared. That's the relationship. Except now for A squared and B squared, on this one, we're going to have to use the distance formula. Now, I know you guys can look at this and go and say 1, 2, 3, 4, 5, and that's clearly 5. And you can look at this and say this is 1, 2, 3, 4, and that's clearly 4, okay? But let's just go ahead and do the distance formula anyway. So for A, the distance formula, we're going to call that the distance, and that is going to be x1, and then we're going to call this x2. And the distance is the square root of x1 minus x2. We're doing this completely the longest possible way to explain how it's going to work. So then what? You're going to say, all right, well, x1 is 1. D equals 1. x2 is 1, 2, 3, 4, 5, 6. So it's 1 minus 6. Square root D equals 1 minus 6 is minus 5. The absolute value of minus 5. D equals 5. 1, 2, 3, 4, 5. We just did it. Now, what about for this one? Now we're going to do this in the y direction. What is the length of y? Alright, the length of y is, well, it's y. We're going to call this y1, and we're going to call this y2. So here we go. B is going to be the distance in the y direction. It is going to be y1 minus y2. B is the distance. y1 is 0. y2 is 1, 2, 3, 4. So what do we have? D equals 0 minus 4 is negative 4. Absolute value D equals 4. Oh, look, we could have just counted that. Instead, we did it the long way. But that's okay, because we're trying to understand how we did this. So what I'm saying is that this distance here is 5, and this distance here is 5, and we got it by comparing the difference in x values. So now we have this number, 4 and 5, and now we can find this formula. Well, So how do we do this? Well, we could simply put this in here. And so we can say c equals the square root of 4 squared plus 5 squared. C equals the square root of 16 plus 25. C equals the square root of, what is this, 41. So let's see, what's that going to be? Square root of 41. Let's just give it a number. How about, I'm going to guess here, it is going to be 6.5. That's probably pretty close. All right. Or we're going to go back and we're going to substitute this for here. And we're going to substitute this for here. So now we're really going to do this the long way, but this is kind of what this problem asks you to do. So now we're going to say that distance c is going to be the square root of, for here, instead of 4 squared, we're going to put y1 minus y2 squared. And instead of 5 squared, we're going to go back and substitute x1 minus x2 squared. That is the distance formula right there. I did the y and the x backwards, but basically that is how they get this formula. That is, well, I hate to admit it, but the book is right, the key concept.